Welcome to Real GMAT Problems, episode 24. Doing real GMAT problems is one of the best ways to make test day more familiar, so let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because this way, if you purchase this current year's official guide, there shouldn't be any overlap between the questions that we're going to work through here. The official guide contains retired problems that have appeared on people's past GMAT exams, so these are going to be super similar to the kinds of questions you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like to, and then I'll discuss my thoughts for what to learn from each question. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're traveling or you're on the go or you're at the gym, but just do your best. If you're in a situation where you can physically write down what you would on test day, like if you're on a plane, I would strongly recommend that. So let's go. This is problem number 85. The problem says a dealer originally bought 100 identical batteries at a total cost of Q dollars. Q is like the letter Q, it's a variable. If each battery was sold at 50% above the original cost per battery, then in terms of Q, for how many dollars was each battery sold? Let me read that again. A dealer originally bought 100 identical batteries at a total cost of Q dollars. If each battery was sold at 50% above the original cost per battery, then in terms of Q, for how many dollars was each battery sold? Option A is 3 times Q over 200. So the quantity 3 times Q divided by 200. Option B is the quantity 3 times Q divided by 2. Option C is 150 times Q. Option D is Q divided by 100. And option E is 150 divided by Q. As always, I recommend pausing here and getting as far as you possibly can on your own. And then I'll jump right into some thoughts here. So, super useful problem to discuss on a few fronts, actually. Number one, word problems involving percents are currently the most common type of question that we're seeing in actual GMAT quant sections. So this is super relevant to that. Number two, clearly this one is tough for a lot of people since 30% of people are missing it, despite it not being about really very advanced math. And number three, it looks like there are a lot of challenges translating and interpreting the question properly. So it's a good opportunity for us to confront some of these difficulties together. Let's break this question down. Let's try to understand why some of the wrong answers are so popular, and let's see if we can build a few approaches for you so you can get questions like these right with ease. I think working through a correct solution first makes sense, so let's do that. The most important parts of a good solution, I think, are making sure you're clear on what the question is asking you and what's being given to you. Sounds like just crazy basic, but it is crazy important in this problem. So what we're asked here is how much each battery was sold for. So we're looking for the selling price of one individual battery. Based on the wrong answer distribution, it looks like a lot of people are missing that one piece and they end up trying to solve for the total amount that all 100 batteries are being sold for, which perhaps obviously is not the right thing to do, but it's a very understandable mistake. So we'll talk about how to avoid that if that happened for you. Once we know what we're trying to figure out, we want to make sure we identify each given value accurately. Note that Q, the variable they define in the problem, is the total cost of all 100 batteries. And it looks like a lot of people either get Q mixed up with the number of batteries or think it's the cost for each battery. So all of these really understandable mistakes. Again, we'll talk about ways you can prevent those from happening for yourself. So the last piece that we're given is the 50% increase, or what you might think of as like a dealer markup. Either way, it's the same thing. So let's start by putting all that together correctly. As I've said many times, there are tons of ways of executing the actual math that I'm about to talk through, and all of those are probably legitimate as long as they work out. So don't stress too much about the specific steps that I'm going to take if you would do the math steps differently. As long as you're not making mistakes and missing questions you know how to do, your process is probably great. Here, rather than trying to force myself to set up a specific equation, like I might do on a traditional math test, I'll probably just try to piece the math together one step at a time. And maybe it's worth just pausing here that that in itself can be a bit of a stumbling block for folks. So I'll circle back on that in a second. But just to kind of preface this, there are times and places to make equations on GMAT problems, and we've looked at many of those already, and we'll probably look at many more as the series continues. But it's also worth mentioning that sometimes that's not actually the ideal way to solve a GMAT problem, and sometimes it's better to just step through the logic one piece at a time. This is just an example of that. I mean, if you wanted to make an equation here, like I was saying before, and that makes it easier for you to execute the math, that's okay. I just want to present something that maybe could be helpful, since I think a lot of people end up having the instinct to do something like this, but then maybe they doubt it or they feel like it's not a legitimate approach, and it's totally legit. So I would start with Q, which is the total cost to the dealer of all the batteries. So if I'm the dealer of these batteries, I'm shelling out Q dollars, and then that's getting me 100 of them. Next, I'd probably divide that number by 100, Q over 100, to isolate the cost per battery to the dealer, since that's what we're told the markup is on. The question says specifically, each battery was sold at 50% above the original cost per battery. Now, mathematically, some of you might be thinking it doesn't matter if I mark up an individual battery or not, and you're right about that. But just in terms of the logic here, I like to stick to the logic of the question as much as I possibly can when doing this, like non-equation, logical step-by-step approach. And I've just found for myself personally that makes me less error prone. Your mileage may vary. So we're gonna mark this up to by 50% because that's what we're solving for, the price per battery, not the total price. So mathematically, the original cost to the dealer of each battery is Q divided by 100. Then I'll do the markup, which is a 50% increase. There are a few ways to do that. One is to multiply by 150 over 100. Some of you are going to be more comfortable with that. Another way might be a little bit more comfortable for some of you, which is thinking Q over 100 plus 50 over 100 times Q over 100. And what you're doing there is taking the original cost per battery and then adding 50% of that cost. Mathematically, it's those two things are the same thing, but some people find one or the other easier to think through. Either way, I'm going to wind up with 150 over 100 times Q over 100, and that represents the price that each individual battery is sold for. Now, if you're not feeling so good about your basic approach to percent translations and calculations, we've got entire math basics episodes devoted to those specific skills if you need to reskill or upskill, and those are going to be linked in the description. So no matter how I choose to execute that 50% markup, I would have 150 over 100 times Q over 100. So I'm in a good spot right now, but as you might be thinking, none of the answers have that exactly. So it looks like I'm going to need to simplify a little bit here. Let's start with canceling some of the fractions. I've got 150 over 100, and I would probably cancel a 10 from the 150 and a 10 from the 100. Some of you might immediately take it down to 3 over 2. I'd like to be a little more conservative than that, and I try to put some steps in between just to make my math more stepwise. I found that gives me more checks against missing questions I know how to do, which is a huge problem for me. But if you go straight to 3 halves and you're getting good results with that, that's cool too. But I would take a 10 out of the top and bottom to get 15 over 10, and then I would take a 5 out of the top and bottom to get 3 over 2. Just for myself personally, I like that extra double check. Helps me avoid missing questions I know. Side note again, if you don't feel super great about your basic approach to fraction math, like this is your first touch or one of your first touches with the exam and you're just getting going, we've got a math basics episode specifically devoted to fraction manipulation as well. It might just be a little bit rusty. You probably were super skilled with all of this math at some point in your life, or maybe like me, you didn't have great math instruction as a kid and you're learning some of this stuff for the first time later in your career, as it were. And that's totally cool. Doesn't really matter where you start with this stuff, everybody. All that matters is where you finish, and that's really just a function of your individual effort. And we're trying to make all the tools for leveraging your effort as widely available and as easy to access as possible. More on that as we go. So those two simplifications would leave us with 3 over 2 times Q over 100. And from there, I can just multiply straight across the top and bottom of both fractions to get 3Q over 200, which is the correct answer and is also option A, as in alpha. So that's a potentially correct solution. Let's step back for a moment And let's think about some of the skills involved in getting the problem right. Of course, we've got the percent math and the fraction math. Like I said, if you need help with those, you know where to find it in the description. But given that most people who've been studying for a while will know that math, I think it's an interesting question to ask, like, why are so many people missing this? And I think it's probably the translation piece. It's more like the logic and the translation of putting things together. Like, clearly there's a lot of right math going on with people getting to wrong answers. So let's dig into that a little bit. B is the most common wrong answer, with 14% of us picking that one. And recall that B is 3 times Q over 2 rather than 3 times Q over 200. That's pretty darn close to being right. Let's think about how someone might end up there. I think it's deeper than just a fraction math error and like accidentally crossing off the hundreds in the denominator. That probably is happening some of the time. I don't have the exact stats on exactly how many people are doing that versus something else, but I think it's reasonable to assume that's happening some of the time. But just given the level of folks in the applicant pool, I just strongly doubt that that's the majority of the misses here. I think people are probably picking this one because they're missing the 100 individual batteries piece of the original problem entirely. I think that's probably what's happening there. And that's understandable. Again, given the time pressure, the ease of missing key information in general, the number of words in the problem. Sometimes it's just due to fatigue, like you're studying late at night or trying to fit a study session in on your lunch break or like things like that. Yeah, I mean, we're all susceptible to that stuff. So that's one possibility. Another possibility that I considered, and I think might actually even be more likely, is that people are thinking Q is the price per battery from the very beginning of the problem. And then they're thinking, oh, cool, I'll just increase that by 50%, and then I'm good to go, which is also like a super understandable thing. And if you thought Q was the original price per battery, then you're like, oh, I just multiply by 150 over 100 or 3 over 2, and then I'm good to go, 3Q over 2. So again, it seems like if a lot of people, 14% of us, are picking B, that most of us probably know the math. Like you are correctly increasing stuff by 50% there. And if you're just starting out or you've struggled with math basics in the past, you might need some more work. But like I was saying, if you put some time into it, you should be good. So I think it's fair to say a lot of people probably know the math. So it's probably more of a process issue than like a content issue if you're picking answers like B. It's just insanely common, as we've talked so much about in this series. You've probably seen how common it is if you've been following the series, and hopefully you've built some good habits to avoid them. But if you haven't, and you find you're making that kind of error a lot, where you're accidentally misinterpreting the given information, then a good tip for that is just implementing a quick double check before you solve the problem. So like after you set everything up, just quickly rereading the problem and asking yourself like, have I understood this properly? So like you read the problem, you translate it, you make some notes about what's given and what's asked, and then you just say, okay, let me reread that and just double check, is my setup the right setup? Because usually once we start doing math, our head kind of goes down. We're not looking at the computer screen anymore, which is how the official exam is served and how a lot of our practice is going to be done. And our eyes go to the scratch paper, and that usually means all our attention goes to the scratch paper, and then we just start doing math. And then we usually do a lot of right math on that potentially wrong setup. So a good way to head that off at the pass is, again, simple double check before you start quote unquote mathing it out. Um, Yeah, I mean, it might just sound so simple that it couldn't possibly work, but a lot of times success on these problems just comes down to super simple behaviors that you condition yourself to do 100% of the time. Like a lot of it is just consistently doing the right thing rather than the right thing being some really complicated stuff. So yeah, I think that's a good, simple, and scalable fix for that kind of issue. Um, like I said, there might be a lot of other reasons people pick B, like just not writing things down at all, or like actual math mistakes. But if one of those things led you to B, my guess is you probably already like understand what to do about that, and it's just about reminding yourself to do it consistently, like I was just talking about. But for sure, let us know if you can't figure out how to stop missing questions you know how to do, and we'll do our best to help out. You can DM us anytime at the GMAT strategy on current social channels, or you can email us if you prefer. Our email address is contact@thegmatstrategy.com, CONTACT at thegmatstrategy.com. Just reach out anytime and we'll do our best. Okay, so Some slight adjustments in your approach to translating questions would probably decrease the odds of picking B. How about some of the other incorrect answers that are popular? We've got 8% of us picking E as an echo, and recall that that is 150 divided by Q. This one, I'm a little less sure why so many of us are picking this one. If I had to guess, though, I think that people here are mixing up cost and the number of units at the start of the problem. So the problem says there are 100 units and the dealer purchases all of them for a total of Q dollars. But if we reversed that accidentally and I thought it was Q units for $100, then I could see someone increasing the $100 by 50% to get 150 and then dividing that by Q to get the cost per unit. Like it's not that big of a stretch of the imagination to see something like that happening. And I've observed quite a few folks doing quite a few GMAT problems at this point. I'm sure I'm in the tens of thousands. And yeah, that happens. That kind of thing happens. So what's really interesting about that is again, all the math and all the logic is perfect right after the initial mix-up. So you can see that there's a lot of intelligent people in the group, but it's just so easy to get turned around at the start of these questions. And that's why I've just been hammering that in this series. I mean, I think I even said this last week, like I apologize if I'm just hammering these takeaways to an annoying degree. I'm not trying to be annoying. I'm trying to be as helpful as possible. And I'm just trying to treat all of you the way I would want to be treated if I could like time teleport myself back to when I was studying. Like, honestly, everybody, I needed to hear it twice as much as I'm telling you. So hopefully you need to hear it less than I do. But yeah, anyway, let's try to fix this. So what could be a good counter to something like that? Like again, if that was you and you made that mistake, the double checking approach I just mentioned will probably help tremendously. It's easy for me to imagine myself making that mistake, rereading the problem, and then being like, oh, wait a minute, I think I got that backwards, and then just making the adjustment and then everything going smoothly after that. But another tip that I've given in a past episode that can work well for this kind of thing is to always label your variables. So if you write down Q, just make sure you write Q equals and then some actual words to describe what Q represents. It's a super simple habit, but really makes a big difference. So here I would write Q equals total cost, and I would write down at some point like 100 batteries or something like that. And that just makes it super unlikely that I'm going to make that kind of mistake that we were just talking through and mix those up. Again, if you made that mistake, totally understandable for a lot of you. You're just getting going. You're just kind of getting comfortable with this. You might be driving. You might be at the gym trying to do these difficult math translations in your head while you're, mid set or mid run or something like that. So, let's have some compassion for ourselves there. But at the same time, let's try to be the right amount of hard on ourselves and not be so easy on ourselves that we're just continuing to allow ourselves to miss questions that we should be getting right and that we deserve to get right because we've done the work to have those skills. So just how I'd recommend thinking about it. Don't be too hard on yourself, but don't be too easy on yourself. And I've talked about that a lot in past episodes, actually. If I know this might sound weird, but if you're not sure how to make that self-assessment, none of the advice I give on this podcast is psychiatric or medical advice, just to be clear, but I struggled with that stuff a lot myself, and we've got a few episodes specifically devoted to that type of mindset. So there's one on how to be more disciplined. There's one on how to be more consistent. You can just search that in the feed. And then there's also a series on how to work smarter, harder, and longer. And I touch on some of those things about how to self-assess and just like get your work ethic and your ability to execute to the next level. That's something I struggled with a ton. And so just have tried to share with you in those episodes what has worked best for me and just help me become, I guess, like more of the kind of person I want to be. Yeah, so that's there for you if you want it. Okay, so we got 14% of people picking B. We got 8% of us picking E. And then we got C, which is another really interesting one. We got 5% of us picking C, which is 150 times Q. My guess on that one is that people think Q represents the cost for each unit. So again, like just a super like easy to imagine mistake reading the problem. So that you're thinking Q represents the cost of each unit. There's 100 of them, so people probably end up multiplying Q by 150 over 100 to increase it by 50%, and then multiplying by 100 units to get the total cost instead of dividing. Again, that makes sense. Not hard to see why someone might get turned around there, but obviously we don't want that for a question where you clearly understand the math. So same two tips that I gave about defining variables and double checking should solve that one if you ended up going for C. Quickly, we've got 3% of us picking D, which is Q over 100. I think folks here might just be missing the increased by 50% piece for a number of reasons. But they do seem to understand that Q is the total cost and there are 100 units. If you're doing Q over 100, that seems like you're understanding that right. But again, same advice, double check what you've written down, and you should keep yourself from missing something like, oh, shoot, I didn't put the 50% in there at all. And it's just a really interesting question because, like, for example, I can imagine myself reading the 50%, writing the 50% down, and then just forgetting about it by accident, doing Q over 100, seeing it in the answers, and then kind of like just maybe panicking or being stressed and being like, oh, that's it. Next question, I got to move on. And just kind of slowing yourself down at the right place in the problem really helps. So you can start to see the kind of mistakes people tend to make, and hopefully you can see a lot of times it's not due to lack of effort or lack of intelligence. I think that's really important to acknowledge. It may just be due to lack of conditioning in order to make the right habits happen 100% of the time. And even with the best intention and the best discipline and the best all that, it still takes time. And sometimes we have to repeat a mistake 2 or 3 times to really make it sink in and make it become a new habit. So don't be afraid to really hammer this stuff with yourself the way that I'm trying to do appropriately to just get it to sink in so that, again, you're not missing questions where you know how to do the math. And that I think is really the saddening part of questions like this when I look at the data is like, man, it really looks like people know how to do the math here. It looks like they've studied, looks like they're putting their best intention into the problem, and yet it's just like going off the rails. And that was me back in the day. So just trying to help you structure this with some simple, actionable stuff that would have really helped me out when I was in your shoes. So it's not necessarily an easy thing to be super consistent. Like I said, we've got that episode specifically on how to do so. If you want some help with that, if you don't, that's probably more than enough on that question. There's a lot to consider and learn, especially given how common those percent translation questions are these days. Like I was saying, one of the most common types. So what I'd recommend there is just pause if you want and just write a quick note to self if you can, or like text yourself or email yourself a quick note to self. If you could only remember one thing from that problem, what would you want to remember? Feel free to pause if you want some more time to think about that or execute on sending yourself a message, a little note to self. When you're ready, let's try another example. This is problem number 86. The problem says, in an increasing sequence of 10 consecutive integers, the sum of the first 5 integers is 560, 560. What is the sum of the last 5 integers in the sequence? Again, in an increasing sequence of 10 consecutive integers, the sum of the first 5 integers is 560. What is the sum of the last 5 integers in the sequence? Option A is 585, 585. Option B is 580, 580. Option C is 575, 575. Option D is 570, 570. And option E is 565 or 565. Again, please pause and give this one a shot. I'm just going to jump right in. This concept of consecutive integers is pretty common on the exam, so it's worth discussing a bit since it's unlikely that you've thought deeply about it in your math education up to this point. And most working adults are not walking around thinking about properties of consecutive sets of numbers. If that's you, then you've got a big advantage on this question, but definitely wasn't me, and it's not most of the folks I talk to every year. So there are a lot of tricks and shortcuts for questions like this, but I think what's going to be most helpful for all of you is to talk through a general solution that's going to work in a wide variety of these types of problems. And then, if you want to go further and research specific shortcuts, you are more than welcome to do that. And just a quick word on shortcuts. Obviously, they are fantastic when they work well. Just be careful with them that apply with shortcuts that apply only in a narrow type of situation. For example, if you find a solution path that's really fast, but it's only going to work in a very limited number of cases, like it has to be a certain type of problem with a certain like feature of it, just ask yourself whether you have the ability to memorize it for that one narrow situation without overloading yourself. I found a lot of people end up collecting tons of shortcuts, but at the expense of generalizable approaches that allow them to get a wide variety of questions right without having to memorize thousands of things that only apply in certain problems. So it's not that shortcuts are bad. Again, they're great if they work on a wide variety of problems, or if you have the mental capacity to actually absorb all of them without hurting the like bigger picture approaches that you're going to use like 80% of the time. And they're also great. Uh, yeah, just anyway, moving on. So if that's you and you have the capacity, that's awesome. But a lot of people I meet in this space every year are not in that situation. They're super pressed for time. They have a lot of other important commitments. They're just trying to keep their head above water with their study time. I mean, that was me. I was working a full-time job. I was maxing out my study time. I was doing the bare minimum social stuff. Just trying to keep my sanity, basically. Um, and if you're in that more compressed situation, then my advice is to steer clear of shortcuts, at least in the short run, unless you can tell you're going to get a lot of use out of them in a wide variety of situations. If not, then learning shortcuts for narrow situations might be counterproductive. I'm just recommending you just be honest with yourself about that, if that makes sense, because you might not see those specific cases where the shortcut applies, and you might mistakenly apply the shortcut where it won't work. And you're going to want a good amount of bandwidth, like a good amount of study time, a good amount of not thinking about other things too much in your day-to-day life to have the just mental capacity to pack all those shortcuts in there. And I just want you to know that's not most people studying for this test. Most of us are working full time. We've got demanding jobs. We've got other responsibilities in our family lives, in our personal lives, in our like outside of work activities, our passions, things we like to do, things that like quote unquote make life worth living. There's all kinds of stuff competing with our attention. And so that's why in this series, I'm going to focus on core strategies you'll be able to use over and over again. And then that way you can memorize relatively few things, but be capable of getting many types of problems correct. That also gives you the freedom to later fill your mind with all kinds of magic tricks that work in narrow cases if you want to, and you have the capacity for that. So again, if you're tight on time, just stick to the basics. That should be more than enough to get you where you want to go. And probably the most important thing to say there is the tricks and shortcuts are not essential for you to reach your goal score. I do want to be really clear about that. Many of us, myself included, have gotten to our goal scores without really any shortcuts or very few shortcuts. But I do want to acknowledge if you're excited about learning lots of different ways to do lots of specific different types of problems and you have the capacity for that, then please, I'm not trying to discourage anyone. That's super cool. Have fun with it for sure. But I'm more speaking to those of you who are really pressed for time and you're looking at a shortcut thinking like, am I really going to be able to memorize this and use this on test day? It's really a question that's worth asking. So with all that being said, a straightforward algebra approach, I think, is a great bet on consecutive integer questions for most people, especially those of you who are self-studying, because it's going to get results on almost any consecutive integer question that you see. It's easy to adapt, it's easy to scale once you get the hang of it, and it's gonna apply really, really widely without having to memorize too much. So I already gave my rationale about that. Let's talk through what that might look like. When you are translating word problems into algebra, a really great place to start is establishing what you know and what you don't know. So this goes a little bit beyond what I was talking about in the previous question, where I was like, make sure you're clear on what's asked, make sure you're clear on what's given. That is also just insanely helpful and important on all GMAT quant questions. But specifically with translating, think about, okay, what do I know and what do I not know? This is wise because when you can identify what you don't know, you can create variables that represent those unknowns. And then you can use the tools of algebra, which is like equations and simplification, to solve for those unknowns and get your answer. Side note, if you want help upskilling or reskilling with algebra, we've got a math basics episode on that linked below as well. In this problem, Let me use it as an example. Think about what we know. We know the sum of the first five. What do we not know? We don't know the sum of the last five, and we don't know any of the individual numbers. And it might sound like redundant or like it might sound like bad news admitting that to ourselves, but it's actually good news because that lets us know what we should create variables for. So let's call the sum of the last five S and write something like S equals question mark to remind us that that's what we're trying to solve for in the problem. And then let's also create a variable or some variables for the numbers themselves in the sequence. There are a couple different ways to do this. One way would be just to make different variables for all 10 numbers, like A, B, C, D, E, F, G, H, whatever, and just list all those out. If you do that, which is a totally fine place to start, eventually you will have to realize that each variable differs by one. That's the consecutive integers part of the problem. Consecutive integers means each number has no decimals or fractions and they differ by one. So like 50, 51, 52, 53, 54, those are all consecutive integers. If you're not sure about integers and you're still getting your terminology back from not thinking about math for a long time, we got a Math Basics episode on definitions. It's the first episode in that Math Basics series. If you realize that each one differs by one, then you'll be able to set up a more solvable situation eventually. Even if you set up 10 different variables, it's going to be really tough to solve that with algebra. It's still doable, but it's going to be kind of like impractically long, probably. So I would recommend thinking a little deeper about that, realizing that they differ by one, and then you can represent all of them in terms of just the first number. So, like if we say the first number is A, then the next number would be A plus one, and the next number would be A plus two, and the next number would be A plus three, and on and on and on. And making that connection, even if you start with the individual variables for all the unknowns, will really help. That's going to make the question a lot more solvable because now we can solve for the first five numbers just using one variable and the fact that we know that they sum to 560. Now, to be clear, you definitely don't have to start the problem making A, B, C, D, E, F, G for every number. You might notice right away that you can do it as A plus one, A plus two, A plus three. And if that was you, that's awesome. Definitely start the problem that way if you can. But for a lot of you, you're just going to need a little bit of practice before something like that becomes automatic. And that's fine. This is, again, is probably just not something you've done a lot of math on in your mathematical career, as it were. Um, yeah, and I mean, also another important point there is it's totally fine and actually like a good idea to take some what I would call in between steps when translating word problems into algebra. I was talking about that with my reducing fractions. Like it might seem like that's slowing me down, but the cost benefit and like the risk adjusted return on that move, if you if you're familiar with that concept, is a lot better than the risk I take on by not doing it. Just for me personally, that's how my stats shake out. You might be different. But if you are like me, then don't fear taking those intermediate steps when translating. Sometimes, if you put pressure on yourself to instantly come up with a perfect equation just from reading, you end up making the problem harder rather than easier. And obviously, we don't want that. Um, Clearly, it's amazing when we can instantly get an equation, but I really don't think that's what most people are doing most of the time. I think most people have to organize things first on their paper and in their head, and then they can kind of start putting the math together and setting things up well. So don't fear taking a few in between steps to make that happen. If you're a whiz with this stuff and you can immediately just create an equation or instantly see the solution path, then awesome, please do that. I'm never going to argue with your results, everybody. If you're getting great results, don't change what you're doing. But if you want to improve and you want to change your results, then it's a very reasonable thing to change your inputs and your approach. So just want to be clear that that's helpful and is sometimes essential because I meet a lot of people who should be doing intermediate steps and they just have this incorrect belief that they need to immediately arrive at some really slick math thing. And sometimes that's just a function of the way answer explanations get written online and in the book. It kind of just magically seems like someone looked at the problem and immediately got an equation. And yeah, I mean that's generally not me. Every once in a while I'll get lucky and that'll happen, but usually I'll be doing some kind of intermediate thing. And I'd recommend you do that too if you find it helpful. So let's say that we all eventually wind up with this A plus one, A plus two, A plus three, and A plus four, which would represent the first five numbers in a set of consecutive integers. We can add all those up and we can set them equal to 560. So that would be A plus one plus A plus two plus A plus three plus A plus four plus A plus five. And then if you want, you can make that equal 560. So if we sum all of those on the left side, we would get 5 times A plus 10. And if that's set equal to 560, we can use a little bit of algebra to subtract 10 from both sides, which would get us 5 times A equals 550. Then we can divide both sides by 5. And if you need some help with long division, we've got that in the Math Basics series as well. But eventually we would get that A is equal to 110. And that's super, super useful. That's super, super useful because now we can figure out what the last five numbers are and we can answer the question. So we'll get to that in a sec, but just a quick recap. This kind of algebraic approach to consecutive integers questions, it's really helpful. Even if you can't get all the way to a equation like the one we just did, using every step, like if there's 100 numbers in the sequence, you'd probably still be able to generalize some of the skills we're putting together here and get like 100A plus whatever that would be. I didn't do the math on that. But again, it's a very flexible solution path, and that's why I'm going over it here. Even though, again, there are some really good tricks for questions like this. Just use those wisely. So we've got the first number, that's 110. So let's figure out what the last five numbers are going to be. The sixth number is going to be A plus 5. The seventh number is going to be A plus 6. The eighth number is going to be on and on and on. Now, some of you might just want to take 110 and just add on to it right away. That's totally cool. No problems with that. Some of you might want to do the algebraic thing I was just doing. And if you summed up the algebra solution, you would get 5 times A plus 35. That's the sum of the last ones, which are A plus 5, A plus 6, A plus 7, A plus 8, and A plus 9. Since we already solved for A, we can just plug that in and get the sum of the last five, which is 5 times 110, that's 550. And then we add 35 to the, we get 585, which is our correct answer, and also option A, as in alpha. Now again, plenty of different ways to execute the math there. If you wanted to just take 110 and count up from that and sum up the last five manually, that also works. But both are good. Whatever resonates with you is cool. So about 20% of us are missing this one, but it looks mostly like just math and setup mistakes based on the distribution. 5% of people pick B, 7% of people pick C, 2% of us pick D, 5% of us pick E. And because all the answer choices are fairly close together, they're all like about 5 apart from each other. My guess is that people either don't know what to do, so they're just randomly guessing, which hopefully now we've filled in a good solution for you if that was you on the first take on this problem. But I think there's probably also a healthy number of people who know what to do, but maybe they just missed the boat by a few numbers in either their setup or their translation. We were talking about how easy that is to do on the previous problem. So I don't think there's a whole lot to focus on from the wrong answer distribution. I think it's pretty much the same stuff we were talking about in translating and setting up and executing well on the first problem, and then just having a good go-to approach for consecutive integers questions, which hopefully I've given you in this problem. And I think if you put those things together, you're probably good to go. Probably good to go on questions like this. So again, if you want to pause and make a note to self or remember a key point, then by all means, please do so. And when you're ready, let's try one more. This is problem number 87. The problem says, a necklace is made by stringing N, as in a variable, the letter N. A necklace is made by stringing N individual beads together in the repeating pattern red bead, green bead, white bead, blue bead, and yellow bead. If the necklace design begins with a red bead and ends with a white bead, then N could equal blank. And then we have 5 options, which I'll read in a moment, but let me reread the problem. A necklace is made by stringing N individual beads together in the repeating pattern red, green, white, blue, and yellow. If the necklace design begins with a red bead and ends with a white bead, then N could equal blank. Option A is 16. Option B is 32. Option C is 41. Option D is 54. And option E is 68. So I recommend pausing and trying to work it out on your own. Similar to the previous problem, I think folks probably miss this one because they don't have a great approach versus just making a math or calculation mistake. I think that's probably less common here, even though it's probably very common on the first question we looked at together. So, of course, it's easy to make those mistakes. So I imagine they're happening. But again, I doubt that's the biggest reason that 20% of us end up missing this question. So, like the previous problem, let's just make sure that you have a good general solution and that you can research the tricks and the shortcuts later if you want to. Most questions that contain some kind of sequence of numbers or items like this one does come down to finding a pattern. That's particularly true, I've noticed, in questions where there's more than 20 things that need to be counted. So if you look at the answers here, there's only one number less than 20. So the odds are that if we wanted to brute force the question and just write out the sequence over and over and over, that probably wouldn't be a good idea because it's possible we'd have to write like 50 or 60 terms. And that's usually just going to take too long. But the good thing about questions like this, when there are so many terms that it's probably just not going to be practical to write them all out, is that you can be almost 100% certain that there's a pattern in there that's going to allow you to figure out the answer without writing all of that stuff down in a brute force way. Most GMAT questions are designed to be at least possible to solve in around 2 minutes. Doesn't mean you're always going to spend 2 minutes. Sometimes you might spend less or more depending on the situation, and those situations are for sure justified. Sometimes you got to go up to 3. Sometimes you should cut it off at 1, or you just get it right after 45 seconds. That's always nice. But it just means that theoretically there should be a way to solve this problem in 2 minutes. And if you're sitting there thinking like it's going to take me 5 minutes to list out 100 terms here, then that's when you want to think, okay, there's got to be some kind of pattern here that I can find. And I'm either going to find that pattern in a reasonable amount of time and get the question right, or I'm not. And sometimes that happens too. We'll talk more about what happens when you can't get questions right later. But in this series, we want to talk about how to get them right. So because writing out 68 terms is probably going to take longer than 2 minutes, there should be a pattern here. So I think just knowing that is powerful because it can change the way that you think about this particular problem and problems like this in the future. And that naturally, I think, leads to a lot of good approaches. I've seen people get a lot of good approaches to click just by thinking differently about it. So here there's a few ways, actually quite a few ways to go about finding a helpful pattern, but one way that's probably going to be useful in the widest variety of situations is figuring out how often the sequence repeats. That's something that I've found to be particularly helpful. So if you want like a generalizable way to approach these, just think like, is this going to repeat? And in this situation, the sequence repeats every 5 beats. And the problem tells us literally that. So we've got red, green, white, blue, yellow, red, green, white, blue, yellow, red, green, white, blue, yellow, over and over again. So let's just consider a simpler problem for a second. What if we wanted the necklace to start with a red bead and end with a yellow bead? It might be obvious, but it's worth mentioning anyway, that then we'd be looking for a multiple of 5 because there's always going to be like sets of 5 beads that start with red and end with yellow. The problem tells us it's always repeating in that pattern. Starts with red, 5 beads later we get a yellow. So in that case, we'd be looking for options that are divisible by 5. You could think about it as like a divisibility problem. That's not what this problem is asking, but it's just a grounding, a foundation, like a starting point to find a possible solution framework, because then we can extend that idea to ending on a white bead. Note that from red to white is 3 beads, but after that, we would need to go another 5 beads to get to white again. So this is me coming back to that concept of like, is there going to be something that repeats? And if it does repeat, how often does it repeat? I think you'll find that really helpful for finding patterns. So the first sequence from red to white is 3, and then every next white bead is going to be plus 5. So if the first white bead is 3 beads into the sequence, then the next white bead is going to be 8. And then the next white bead is going to be 5 more, which is 13. And then the next white bead is going to be 5 more than that, which is 18. And then 23, and then 28, and on and on and on and on, adding 5 beads each time. Now, at that point, there are a couple different paths you could go down. You might spot the pattern of the last digit is either a 3 or an 8. That works well here because there's only one option that ends in a 3 or an 8, which is option E, echo, which is the correct answer, 68. Or you could think about it as a remainders problem. A lot of people like this, I've found. It's not for everybody, but it's for a big segment. If you think each 5 beads, the sequence repeats, then I'm going to need, and then after that, I'm going to need to count 3 more beads into the pattern to end on a white. Then you can start looking for things that are a multiple of 5 and then plus 3. So a multiple of 5 plus 3. And 68 is the only option that fits multiple of 5, 65 plus 3, 68. A little bit different way to spot the pattern than just ending in a 3 or an 8. Both work. If you're not sure what I mean by remainders, you might, or you just want to be more solid with this concept of remainders, whole number remainders, that is, we've got a math basics episode on remainders linked below too. Honestly, there's probably a lot of different ways to think about how to spot a particular pattern like that. But I think those two patterns are probably the most likely for people. But both of them are going to come from that idea of repeating, if that makes sense. So you're going to try to figure out where's the repetition happening and how can I leverage that to make the problem easier for me. So basically, if there are a lot of terms in a sequence, you want to try to find the pattern. If there are fewer than 20 terms, you might be able to just write it out and brute force it. But if there's more than 20, finding a pattern is probably going to be the way to go. If you can spot the pattern right away, awesome. But more often than not, you're going to want to write out part of the sequence and then use that to try to visualize what's going to happen next and see if you can figure out how to use repetition. If you do that, as simple as that hopefully sounds, on these kinds of problems, whether you think about them as remainders or think about them as different kinds of patterns, you should have success. Like it should just work out. I know that might sound crazy, but again, I've found that a lot of these questions can be reduced to these really simple, straightforward, but like widely applicable approaches that, yeah, they might not be the fastest 100% of the time, but they're just like incredible bread and butter approaches that you can make use of over and over and over again if you're in that time constrained, energy constrained, memorization constrained kind of situation like I was in. I wish someone just took me through, like I'm taking you through right now, some examples of stuff and proved to me like, hey, this is going to be useful to the point where I was like, I should probably learn how to use algebra on consecutive integers questions like that. I'm convinced. And that would have just saved me just an absurd amount of time and pain. So hopefully I'm saving that for you right now. Once again, if you want to pause and just make a quick note to self based on anything that we've covered today, now would be a great time to do that. If you have questions on any of this stuff, feel free to reach out to us anytime at the GMAT strategy, or again, you can email us contact@thegmatstrategy.com. We're always happy to help. We love hearing from all of you. We've found that this community is just a group of really awesome, really motivated, hardworking, industrious people. Like you definitely deserve success as a group. So we're happy to facilitate that as much as we can. And on that note, just so you're aware, we do offer a free service where you can book a call and speak with us live. I think this is especially helpful if you're just starting out and you want an overview of possible paths that you could take, and you're trying to make a good decision from the beginning about how to do this efficiently, or if you're in a situation where you've been studying for a while and you're not happy with the rate of your improvement, you're not seeing the results that you want to. For example, if you've seen some score drops, if you're not happy with your current plan or your current provider, they're not treating you the way you want to be treated, or you feel like you're not getting what they promised you would get. That's obviously a really unfortunate and sad situation, but it does happen. Then we'll hop on the phone with you, and sorry, it's usually over the internet these days, typically like a Zoom. We'll figure out what's going on well. We'll figure out what's going well in your studies and what's not going so well, and we can make some recommendations for how you can make fixes and see faster progress. I've said this before, but I just want to repeat it. Like this is something we've been trying to work toward offering for free to the community for a long time. We're finally there, and I'm just really excited about it. I'm really happy with the results people are getting. I do want to be clear, there's no obligation for the call. It's not a situation where we're going to pitch you on something or there's going to be some weird catch or gotcha moment in the middle of the call. I don't believe in that at all. I think that's super weird and awkward and messed up. Definitely not the kind of relationship that we're trying to build with anybody as a company or as people. We're there to help. And we won't mention any of our paid products or services unless you specifically ask about them. If you ask about them, then we will tell you about them. But really, the purpose of the call is not that. The purpose of the call is to give you some advice and some options based on your situation, and then you can take that and do with it whatever makes sense to you. Having said that, if you are interested in working with us directly, specifically, just let us know that, and we are happy to discuss our approach on that call. Our programs are definitely not a fit for everyone. We're totally at peace with that. So there's never any expectation that you're going to ask about working with us directly or that's going to happen at all. We just want to help you. We want to keep you from making the same mistakes that we did. And also, if you are interested in working with us specifically because you like our style, that's awesome. We appreciate it. Thank you. But again, it's not expected. So I just want to be clear about what happens on those calls and what our approach to doing those calls is like. If you want to get a better feel for what we do and how we do it, and you're a little on the fence about it, just check out the video on our website at thegmatstrategy.com, and that'll help you get a feel for our style and whether it's a good idea for you to talk with us and get our help. So if you're happy with the rate of progress or you feel like what I just described is just not for you, that's totally cool. We are going to keep doing our absolute best to help you out as much as we can right here. If you want more tips and strategies for optimizing your performance on the exam, please head to the website, thegmatstrategy.com. It's linked in the description of this content. And check out our video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.